Synodic, we're trying to automate computer vision. So I guess I can just start with a general definition of computer vision. So in general, computer vision is trying to extract information from like images or video. So at Synodic, we focus on a subset of that, which is object detection. So object detection is given an image, can you pick out where the object is in the image and also tell me the size of the image so I know where it is relative to the camera.
Something that humans don't have is we don't have a filter. Now we may filter our answers based off of what our audience is. We really don't have filters en masse, really. Like if you take a whole population, there will be people who are going to say those really offensive things, and there's going to be people who keep it to themselves. But the real spectrum that you get through humans, through every person being completely different on that spectrum without having a common filter set, I think is something that AI will never replace, when each AI's goal is to have that common filter. So I think we have a broader spectrum of diversity, of thinking, of life, really, that can never be replicated.
Hello and welcome to Indian Diaspora. This is your host Rahul. Today we have two teen prodigies from the Indian Diaspora in Massachusetts, United States of America. They are Arjun Goray and Sean, who's not Indian, but he is partnering with Arjun. Both of them have created an AI company at a very young age. It's called Synodic.ai. They are pioneering vision for the computer using AI. They're going to share exciting stories of their journey of entrepreneurship at such a young age of 17 years. Arjun and Sean, welcome to the podcast.
Thank you for having us.
Thanks.
So, as I mentioned, you have launched a company in AI at such a young age. But before that, let us understand both of you. Arjun, talk to us about you. Where do you come from?
So I'm 17 years old, senior in high school. Synodic was actually launched in May of last year, so when I was a junior, but 17 now. But I'm a homegrown Bostonian. Was born in Wilmington, lived in Wilmington for a few years, and then moved to Sudbury, Massachusetts, where I currently live. I was always a super big sports fan growing up. Strong feelings about the Patriots, Celtics, even the Red Sox a little bit. Never much of a hockey fan, but like the Bruins too. But I really got into the technology space when I was in middle school. When I had my first Raspberry Pi, when I could tinker with it, learn more about the internet, watched YouTube videos, started coding on my own. And I really, really got deep into the weeds of computer vision in sophomore year when I joined the robotics team. And I met Sean, and it really went from there, where we wanted to add autonomy to our robot. And it's just been a journey since then.
Excellent. Sean, tell us about yourself.
Yes, so like Arjun, I'm a senior in high school and I'm also 17. I live in Sudbury with Arjun, and I've always loved technology. So from a young age, in like 4th grade, I started doing robotics. And then since then, I've progressed through different competitions. I compete in the first robotics competition with Arjun, as well as the World Robot Olympiad, where my team is the 2-time United States national champion. In addition to robotics, I also really love the outdoors, hiking, running, and I'm a Boy Scout, and I recently became an Eagle Scout. So that's how I spend most of my time. So
that's amazing. Did you say 2 times robotic national champion, Sean?
Yes. Yeah.
That is excellent. We'll know more about that. But before that, tell us about Synodic. What does the company stand for, and what does it do?
So Sure, I can talk about that. So Synodic, we're trying to automate computer vision. So I guess I can just start with a general definition of computer vision. So in general, computer vision is trying to extract information from like images or video. So at Synodic, we focus on a subset of that, which is object detection. So object detection is given an image, can you pick out where the object is in the image and also tell me the size of the image so I know where it is relative to the camera. So we first wanted to do this, as Arjun mentioned, on our robotics team. We wanted to train a model to go and detect where the game objects that we need to pick up are. So during the 15-second autonomous period, we could go and pick it up automatically rather than having to write handwritten code, like go a meter forward, then turn 90 degrees, then another meter, because that's just not accurate. So we, Synodic helps users train object detection models. So users upload giant data sets of thousands of images, and then we help them label where the objects are in their images, and then train a model that they can use in the real world. And I'm sure later we'll get into some examples of real world applications.
So
we'll
I
get into
understand
that
it's
use case.
object detection using AI.
Yes.
Excellent. Yes, Arjun, carry on.
Yeah, so there's three main products that we have. We have really the image collection process, where it's like you can either go and take tens, hundreds of thousands of images using a camera, but that could take hours, days, months, could cost thousands of dollars, tens of thousands of dollars. But really, we want to automate that process. So instead, we developed a catalog of roughly 2 billion images, which users can use. We have some AI search tools, and so we can really help you find the images that you need really quickly, on the order of 2 to 5 minutes. That's really quick. You can just filter through that data and really get that object detection data set that you need. Our next tool is auto label. So you have your images, but you need to really have that ground truth. How do you train the model? So you need to tell the computer what it needs to do. And the way we do that is we have some larger AI models. Think like Google's Gemini or some competing products. And we have it draw bounding boxes or little boxes around each object in the image. So that's the auto label product. And then our last one is auto train, where we automate the whole training process. So instead of you having to write all that code or use another platform, we do it for you. We do it a lot faster because we use the highest end GPUs and we have efficient code. So we can get that whole process with all three products. So idea to model really in under 20 minutes.
Yeah. And I think it's important to add that, like, on other platforms, as Arjun mentioned, collecting the data set itself could take days or weeks, where on Synodic, you can just do it in a few minutes. So it's really like revolutionary in that sense. And then the next steps after that also are incredibly time consuming. Like labeling by hand it's just a very tedious and monotonous process. And by automating it, it isn't perfect, but we've designed our UI and our product so that you can auto label the data set, and then you can go back in and fine tune what the model made mistakes with. So you get a really amazing data set. And then the auto training is probably the hardest part for a lot of developers, because there's a ton of knowledge that you need going into it about like GPU configuration, the right packages. And I don't want to get too technical, but like it's really hard for a developer, and it would take a couple of weeks for like a regular developer to learn how to set everything up. But we just automating it, they can just use an API rather than having to learn all of that themselves. So it just saves a lot of time.
So labeling or annotation is something that you offer. And Arjun, I think you mentioned selection of images. You mentioned 2 billion images. So selection of images very quickly. So if you just put this in bullet points, right? So one was object detection. Second is labeling or annotation. What are the other features that your platform provides?
So another thing we have is inference. Something that is really, really, really important is I give you a frame, a picture. How quickly can you give me the object in the frame? Is it going to take 5 seconds, 5 milliseconds? That's a big difference, especially when you have a video where you're streaming at 30 frames per second, 60 frames per second. So that's really important. Something that we have developed is a really fast inference tool using the cloud where we get up to 20 to 30 frames per second, where our competition is around 5 to 10. So we can get you much faster response times with the object detection models. That's another feature. And then the last one really is that auto train feature, the automating the whole process. So you don't have to spend months learning how computer vision works or hire a whole suite of computer vision developers.
Excellent.
We cover that process.
All right. So I think we get a very good idea of what Synodic brings in as a platform. And I'm reminding my audience, both of them are just 17 years old. So that is fascinating, Sean and Arjun. Now, you mentioned competing models, right? Let's take ChatGPT 4 Plus, for example. It also provides, auto detection, object detection through camera. How is what you offer differentiated from ChatGPT 4 or other platforms in the market?
Sure. So I can take this one. So ChatGPT is running on like a giant model. So I think, if I remember correctly, it has around 400 billion parameters. If you compare that to the models we're working with, they have around 30 million. So that's almost what is that? Like 10,000x less. So ChatGPT is one, extremely expensive to run because you have to have infrastructure to support all of those parameters, as well as it takes a lot longer. So if you submit an API request to ChatGPT, it might take 200 to maybe 1700 milliseconds to respond, where our models will respond in less than 100 milliseconds. So by distilling this information down to a smaller model, you're able to have faster inference and cheaper inference, which is really what our customers are looking for.
How do you ensure accuracy when you tune for faster response to queries?
Something that ChatGPT is it really is just a master of all. That's what they claim it is, but it's not perfect, right? It may be able to detect an object, tell you where it is in the frame, but will the bounding box be, or the box be tight to it? If I hold up a phone, will it be perfectly on the edges? No. What we do is our models, we iterate specifically for that phone, for that object, so that whatever imperfections there are, through more iterations, it'll get better and better until it's almost perfect. ChatGPT 4 is not trained for that object. It never had those iterations for that object. So it will almost every time produce different results. Our models really are consistent, they're efficient, and most importantly, they're fast.
Excellent. So, here we are really discussing as geeks all the bells and whistles of this. But let's talk about practical applications in real life. I think for a lot of our audience who may not be from a tech background, this part of the conversation may be more relatable. So, a computer that has vision using AI. Arjun and Sean, give us 3 use cases where this technology could be applied for betterment of the society or bringing value to businesses or people.
Sure, I can start off. So in the manufacturing industry, there's a ton of different use cases, as I'm sure you can imagine. So I can just name a couple. So the first one is if objects are coming down the factory line and you want to track the rate of production, the object detection models are perfect for this, because imagine if you had a lot of factory lines today use lasers to detect that. But if 2 objects are going down, they're triggering the laser once, so it's quite inaccurate. Where you can have a top-down camera and it can detect all of them perfectly. And in terms of manufacturing, there's a bunch of other applications, like using that same top-down camera to use a robotic arm to pick up the objects, or doing quality control. So if you're talking about metal, you can be looking for scratches and dents. Or if you're talking about an electronic PCB, you could be looking for misplaced connections that you need to resolder. So one final example in a factory would be safety compliance. So making sure all your workers are wearing the appropriate safety equipment, hard hats, or maybe if we're talking about a hospital, they're wearing PPE. So that's just a few factory examples, but I don't know, Arjun, do you want to give some other industries?
Yeah, he gave some good industries. I'll just go a little more in detail. I'm just going to use an example that I think we can all maybe relate to. If anyone's really bought a new car, what's the first thing you do when you go pick it up? You're going to take a little 360, right? You're going to look to see if there's any dents, there's any dings, there's any misses in the paint job. And a solid number of the times you're going to find something, and it's on the company to fix that. They're incurring that whatever $500, $1,000, $2,000 cost sometimes, and it can even go up to $10,000 if it's and more than that if it's an issue in the frame where they have to send it back to the factory. So the idea here is that before it even leaves the factory, before the whole car is assembled, if each part can go through that QC process through a computer vision model, which is a lot more efficient than a person, so they can do a lot more products at once. It can process a lot more data. It's a lot more consistent. Who knows if a first-year manufacturing worker versus a 10th-year manufacturing worker are going to be doing the same quality job. So really, we're seeing a world where computer vision is in the factory, where when you pick up that car, there are no issues. Every time you do that 360, you're never going to find anything. It's like it's saving the business's money. It's making it more trustworthy for the consumer. It's really a win-win scenario that we're looking at.
Yeah, excellent. Great real world examples of how AI can be used to increase productivity, safety, healthcare. Are you working in the healthcare space as well?
Some of our users are training models for like the safety compliance with PPE, like I'm talking about.
Yeah.
And then in terms of like biology and agriculture, I know it's a little bit biology is sort of similar to healthcare, so I'll stick with that.
Yeah.
But a lot of users are detecting certain items inside a blood specimen that maybe aren't supposed to be there, or they're counting they're taking their chemical samples and they're counting the number of objects in there. So this is sort of, I'm not doing a great job of explaining, so I'll give an example. So let's say you have like a blood specimen and you're in a research lab and you have maybe like 1 million specimens that you have to go through and count the number of white blood cells in them. It would make absolutely no sense for a human to go and count that, where you can train a model on maybe 500 of those images, and then you get the model to predict everything else. And then if you really want, you can have a human check over that, but it's not even necessary because you can have such high confidence based on different parameters that you set the model to, that the model will perform well. So you're saving humans a ton of time.
Yeah.
And
Sure. Now, does your model hallucinate? AI algorithms are known to hallucinate or give erroneous output, but still be confident about it. Is there possibilities of hallucinations? And if yes, how do you protect the algorithm and the outcome against it?
So, yes is the answer. Any machine learning model has the ability to hallucinate until there's some radical new innovation from MIT that that will change that. But right now, everything will. But our models have something called a confidence score that you tweak when you're doing inference on it. So that means the model, when it produces an output, also attaches a confidence value to it. You really want the confidence value to be above 80%, but sometimes it's less. So if you're in an industry that really needs high quality outputs, you should be capping the confidence value at a high number. So you should not produce any outputs that are less than a set value, per se, 80%, right? So that's up to the end user. You can change that anytime you want. You can really tweak it to see what produces the best outputs for your application. But that is really important. So I'm glad you brought that up.
Excellent. I like the humility that you present here. AI algorithms can be less humble. And I like the confidence score that you are providing in the output. Now, Arjun and Sean, I want to go back to the genesis of how this all began, right? Again, reminding both of you are 17 years old. How many years back this journey started for both of you?
Yeah, so I guess I can start talking for myself. So I became interested in like AI and all this stuff back in 8th grade, I think. I saw this
Okay.
demo from OpenAI of like these virtual like agents, which are like video game characters playing hide and go seek, and they became like so intelligent. I thought this was amazing. So I need to learn more about it. So back then I wanted to learn more about it, and I wanted to learn more about neural networks in particular, which is sort of like the building block of all these models. And so I created like a Python package to try to help me learn that. And I tried to make all the math super simple, so hopefully other people can understand as well. But that's how I really got into it. And then I think Arjun and I continued to develop this when we joined our robotics team, and we wanted to implement some object detection algorithms. And back then, we had a data set of 3,000 images that we hand label ourselves. It took dozens of hours, and the model we were able to produce wasn't that great, because to produce like an amazing model, you need like 20 to 50,000 images. So we were trying to find a way that we could crowdsource this, because each FRC team that wanted to do this had to do it themselves. But if each of the team has their own model, has their own data set, like why don't all the teams just combine it into a giant data set with really great models? So we built a software to do that. It was called Dataset Collab, and it was like the precursor to Synodic, and it was extremely successful. We had like over 500 teams using it, and everyone loved the product because it was just a clear value proposition to them. Like, we're helping you improve the confidence in your model, and you're helping improve other people's models. So it was a win-win situation.
Mm-hmm. Arjun, when did it start for you?
So, we're nerds, so we knew about OpenAI before 2022, before Chachi BT was released. But yeah, around the same time, around 8th grade, just really looking at how we can almost get rid of some of our human inefficiencies. So I think, funny enough, I didn't know this. We didn't talk about this before, but I also had seen the same demo of basically training characters to play video games better, and I was like, how can I use this to beat my friends? I was playing Fortnite at the time, so how can I like beat them using computer vision, or not? Sorry, not computer vision, machine learning. But that's really where I got into it. But that was at the low level. Where I really got into it was in 10th grade, when both of us started thinking about how we can make our robot autonomous, because it's like it can really make things a lot more efficient, and especially in the competition that we compete in, which is called First Robotics.
Yeah.
There is that integral first 15 seconds where you are not allowed to control your robot. With a controller, you have to do everything fully autonomously. So being able to be agile with computer vision, so you can just see an object, move towards it, pick it up, and then achieve an objective with it, is really groundbreaking, and it can get you much higher placed in the competition.
How old were both of you in your 8th grade?
This is 4 years ago
Like
now. So
13 or 14.
4 years ago.
13,
Got it.
14.
All right, got it. So what I was getting at is that how long the journey has it been since when you started and until now? So in 4 years, you have produced this platform now, which is very differentiated in the market, and real-time applications of this technology. That is amazing.
Thank you.
Why am I asking all these questions, right? It's about the process more than it's about the results, right? So your education, your community, your parents, yourselves, of course, all of this shapes how you approach your life, your goals, and the results you have produced so far. Yeah, I'm going to make some assumptions. The Massachusetts school system, Massachusetts has some of the best schooling systems in the United States. It's called the brain of the United States, right? Talk to me about how did the Massachusetts schooling system influence not only your interest, but the execution of your goals? And then we can move towards your community or your parents. How did they support you? But first to the first question about Massachusetts schooling system.
So one message that I think the Massachusetts schooling system really did drive home and really instilled in every person in it is the idea that you should do whatever you want. Now, as a kid, that's really vague. It's like, what do I like? How do I find what I like? And it was really like, it was providing an uncertain future, certainly. But I think it is the reason that I was able to develop this real fascination, this obsession, whatever you call it, with computers, computer science, computer vision, machine learning, really. And it's because they encouraged me from my kindergarten teacher all the way till now to like really just do whatever you like. And that's partly because we do have a fabulous education system with phenomenal teachers. We do have the luxury of having some of the lowest class sizes in the nation, some of the nicest facilities, great funding, access to clubs, access to other resources. So we really do get to do what we want, and we get to think how we want, and we have the resources to really fulfill that. But then the other part really is what happens at home, right? My parents always did want me to do what I want back home. My mom graduated with a computer science degree. I'll tell you, she does not like computer science. Funny enough, I'm a computer science geek, but she did not want me to fall into that same trap where she felt forced into getting into something that she didn't really like. She wanted me to find what I wanted. My dad did like what he wanted, but he's not in mechanical engineering, what he graduated with. So he wanted me to do something that I liked as well. So it was really that two-pronged approach where the school was telling me that message, really find an interest and stick with it if you can. And then at home was the same message. So that really did allow me to just find a passion. And, once you get into that passion, it's really hard to get out.
Excellent. And kudos to your parents for letting you choose your destiny and what you love. I think that makes a lot of difference.
I mean, I'll tell you, it wasn't as simple as I thought it would be. My mom always thought it would be a doctor. I'm not a doctor. I will never be a doctor. I really don't think. But, she supported me. And I think that's what made a big difference.
Yeah. Sean, how was your experience with the Massachusetts schooling system?
Yeah, it's been a great experience. I'm truly grateful for everything. I think I've always been interested in math and science from a young age, as I'm sure Arjun is as well. And there's so many opportunities here to learn more about math and science and computer science. For example, last year, I really wanted to do research. So I just asked one of my teachers if we could do an independent study focused on research, and I was able to use neural networks, which are the same building block as Synodic, and apply that to national data on kidney disease. So it's so cool that I was able to bring something I'm really interested in into the school system, which I think in general people think it's really rigid, but I think in Massachusetts we're really the system in Massachusetts really allows it to explore what you're interested in. And I think my parents have also always supported that as well. I remember when I was young, my dad would bring me to try all these different things. I tried soccer and baseball and all these things, and eventually I didn't stick with them, but I eventually found robotics and cross country and other stuff like that where I really enjoyed it, and they just afforded me the wonderful opportunity to try out a bunch of things and see what I really love. So
excellent. Shout out to every teacher out there, who from our schooling system in Massachusetts or across the nation, who enables and empowers their student to dream and achieve it. Sean and Arjun, would you like to call out somebody from your schooling system who might have played a role here besides your parents?
I mean, I think it's hard to only call out one.
Yeah.
But I don't know about Sean, and we had the same teacher, but there's our freshman year teacher that really did change the way I think about really almost everything. He was, an earth science teacher, so I encourage you not to think it's the most boring subject in the world, as I did when I first walked into that class. But he had a way of captivating students. He would lecture for 53 minutes, and we had never been in lecture classes before. But he made it interesting. You would lose time. You would walk in, walk out, and it felt like it was a whole different day almost. It was a whole different perspective that you had, because you're almost like you feel insignificant in the whole world, and he really did portray that concept. And I know I'm just talking about earth sciences, but it was just that teaching style, that obsession, that passion for something that really changed the way I thought about topics, about obsessions, about passions. So like I really do want to call him out. His name was Dr. Pegram. I really do hope he finds this somehow and he can receive this thanks. But
how do you spell his name? P-E?
Pegram, Pegram.
Got it. We'll ensure he gets it.
I hope so.
Excellent. I get you, Arjun and Sean. It's not about what you learn, but it's about how do you think about what you learn, and which is what equips you for life.
Yeah, he really.
Besides yes, Sean, carry on.
So, and I was just gonna add to Arjun gave like an amazing description, but he really instilled like a curiosity in the sciences for both of us. I think.
Yeah.
Like
100%.
I'm going into high school. I would say I was like a math and computer science guy, but like coming out, I'm like really interested in science as well as math and computer science, and he really instilled that in us. So.
Excellent. Now, besides your education system, let's talk about yourself and your process and your methodology, right? You mentioned YouTube videos, but I want to understand more. In the last 4 years, since your 8th grade, what approach did you follow to absorb more knowledge, insights, experiences, and so that but also talk to us about how did you execute as well, so that you do, besides what you know, right? That helps you reach this stage in life. What was your individual approach beyond your schooling systems and your community and your parents to create something this novel?
Yeah, so I think everybody knows that people say that quality is better than quantity. I kind of took the other approach. I went in quantity over quality. So I would just watch literally everything related to technology. It didn't matter if it was like a new software update in a car or a new like completely different NASA telescope. I'm citing the James Webb telescope here, but really I just looked at everything and I tried to learn about everything, and I would just go through these random obsession phases. And I'll just give a few examples, but like at one point I was like super obsessed with crypto, right? Like getting into the weeds about it, and not really on the finance side, and a little bit, of course, but really just like the technology itself, how it works, how it can change our banking system, how we can replace Swift, the payment network, with crypto blockchain transactions. I went through spurts of like building my own computer, things like that, and I would just get really obsessed with it. One random example is I like also became obsessed with like solar panels and how that worked, and I actually got it installed in our house. But that's just like, you can see I'm really just like throwing darts on a board and it's just like landing wherever, and I just stick with it. I do think it's different about machine learning because I did like those, but I didn't really have a passion for those. So once I almost hit the bullseye per se with machine learning, I think it is something I'm going to stick with. But really, I just took the quantity approach where I just tried everything, and I think I finally found something that I really do love and want to stick with.
Ironically, this is how an AI algorithm would learn on a lot of data sets.
It's true, yes.
It really is ironic. So I'm calling me an AI, and I'm coding the AI. So
Elon Musk's brain machine interface is just around the corner, right? Like the synapses of the human brain and the neurons, and the digits, zeros and ones of the computer. We all have started behaving alike.
Yep.
Sean, what was your approach?
Yeah, I think mine was like coincidentally, or probably not coincidentally, very similar to Arjun's. Like for like the past like 4 or 5 years, I've just been like absolutely obsessed with like computer science and learning more, building my own projects. Like most of my projects were like not successful at all. They could be viewed as like a waste of time, but they were like the exact opposite. Like I learned so much, and through like just keep going at it, even if I fail, like it's brought me like so many cool opportunities, like starting Synodic. If I didn't like just want to learn more about machine learning and computer science, I wouldn't have had the skill set to work on Synodic, but because of that, I was able to work in Synodic and do robotics and so many other different opportunities. So I think, like Arjun was saying, like the quantity is so much more important than the quality. And if you're just working at it every day, you could get there.
So let's turn even a bit more specific for the benefit of maybe a younger teenager watching this. So besides YouTube videos, everything under the sun technology, what other sources of knowledge did you refer? For example, did you go to libraries? Do you read Scientific American, for example, right? Talk to us. What are the knowledge sources besides YouTube videos you latched onto?
I think for like computer science in particular, and especially with machine learning, there's a lot of amazing like blogs. So if you want to learn about like the transformer architecture, which is the technology behind Chachi BT and all the LLMs, so there's so many blogs that break down all the math in particular. And I think the blogs offer something that the YouTube videos don't, with their interactiveness and as well as they're just text explaining, and you have to like really think about what you're watching. Like when you're watching a video, you can just forget for 5 seconds what's happening, and then you're totally lost. Where the blog, you have to read through each step. And I also think, I know you mentioned journal articles, but those are absolutely amazing for machine learning. Like if I want to go and try to like understand a new model, I'll often go read the journal article and then try to take the code that's published with the journal article, run it myself, and get an understanding that way. Or I'll even go as far as to like implement the code myself, so I get like a really concrete understanding. So I think both those are really great resources.
Thank you for sharing that. Arjun, anything different?
Very similar approach. It's kind of like a 3-level approach for me, and I think he pretty much described the same structure. But it's like I would learn something new in either a YouTube video or like a Twitter call out or a Reddit post, something like that. But then I'll almost always go find a Medium article on it. And those not familiar, it's basically a platform where anyone can publish an article about something. And so you can basically get the written form of a video, but like Sean said, it allows you to get deeper into it, make sure you really understand it. And so you can like dive deeper into the subject versus forgetting 5 seconds of a clip. And then the next approach, the next part of it is really getting into the nitty gritties, where you go to the GitHub repos of a topic, where you read the research papers, the journal entries, things like that. So that's really how I do it. It's like you learn about something, you go a little deeper, and then you really get into the weeds of it. So
Excellent. What I definitely observe is that you guys really go to the specifics of knowledge seeking in this space, and you're using innovative source of knowledge besides just a YouTube video, which is what I assumed earlier. So thank you for sharing that. Now I'm going to ask a very difficult question to you. Pay attention. So there are 3 things. I know what I know. I know what I do not know. I do not know what I do not know. Right? So in the realm of technology, this technology, what do you think you don't know that you don't know?
Sorry, let me think about this for a second.
I know that that's a difficult one. We all have blind spots.
for all those watching, this is not scripted at all. So this you really got to think about this one.
I think I can talk about like our experience at Synodic as in terms of like past experiences where we realized like there were blind spots in like what we knew. So when we built Synodic originally, any like software engineer would have been looked at it and said like, this is the stupidest thing ever. You guys should change XYZ. And then as we've been continuing to work on it, we adding new features, we're realizing that, oh shoot, there is a reason that everything's done this way. We got to upgrade it. And at the start, we would have had no idea to go and pursue that path. So I think the more like we learn at Synodic, the more we upgrade our systems and we choose new like technical architectures for our products, and we just keep realizing that we don't know what we don't know. And I think it's just sort of humbling how we keep realizing that there's so much still to learn.
Yeah. And let me also explain why did I ask this, right? Arjun, you mentioned about quantity over quality, right? perhaps there comes a time, and I think you were alluding to that, where you have to stick to a genre, a category, an area, and then do quantity over quality, or maybe quantity and quality in that space, right? And if you look into any scientist, even Einstein, right? The more they discovered the world, the more they know, the more they came to realize that they do not know, right? Even, for example, Big Bang, we do not know what happened before the Big Bang as humanity, right? So the question is to understand what we do not know, and the growth begins from there. So having applied this in the realm of AI and computer vision, I'm curious, where do you take the next 17 years of your life from this realization? Arjun, did you want to say anything else about my question?
Yeah, it's a very similar response. It's kind of like you just have to accept it.
Yeah.
You're not going to know it anyways at this moment, but
No.
you're kind of gambling that you will figure it out later. So whether it is sitting on that feature release, bug testing it by yourself for another 3 weeks, or just release it in the beta release for other people to see, and then have them tell you what you did not know. It's really what you want to achieve. If you want that speed of innovation, you just have to accept that you don't know some things and you're going to have to figure it out later. So I think that's kind of what we were going for. We always went for speed over everything else. We wanted to be the fastest innovators out there. And that was one realization we had. We were a little naive when we started. We were like, why do you need beta tests? Just get it right the first time.
Yeah.
But that stifles innovation. You can't push three new features out in a small time frame if you have to fully test out everything, which we realized pretty quickly is not possible. So just have to accept it and take that leap of faith.
Yeah, I love your wisdom. And if you apply lean startup concept by Eric Rice of first MVP, right? You launch your first MVP and then you iterate your way towards the second, third, and the final iteration. And I think that's a great answer that you give. That's where what you do not know come from the wisdom of the crowd that is using your product or your value proposition. Love that. Next question, Arjun and Sean. Based on your knowledge and background, what do you think AI will never able to provide that humans do?
I think I have somewhat of an answer there.
Yeah.
Something that is really important to an AI right now, and something that is hard coded into it, are really safety checks. Right now, before a Chachi BT response is sent back out to the user, it's checked to see, is there anything offensive here? Is there anything that could provide some slightly misleading answers? And is it perfect? No. Are they stopping every case? No, but they're trying their best, and it's continually getting better to avoid making those offensive comments, making those tweaks. Something that humans don't have is we don't have a filter. Now, we may filter our answers based off of what our audience is. We really don't have filters en masse, really. Like, if you take a whole population, there will be people who are going to say those really offensive things, and there's going to be people who keep it to themselves. But the real spectrum that you get through humans, through every person being completely different on that spectrum, without having a common filter set, I think is something that AI will never replace, when each AI's goal is to have that common filter. So I think we have a broader spectrum of diversity of thinking, of life, really, that can never be replicated by AI.
Excellent reflections, Arjun. In other words, correct me if I'm wrong, is the right answer moral compass? Meaning humans in one culture, let's say Greek, would have a different moral compass for what may cause hurt. You shed filters. And in American culture, it might be different, right? So different moralities or ethical standards. And how does an AI know what is the right ethical standard, means what's right or wrong as an answer, not to hallucinate, from a cultural perspective, right? But also from an era's perspective. So think in Victorian British era, certain norms will be okay, but in modern 21st century, certain norms may not be okay if that was okay in the British era. You know what I'm saying here? So how do you know what's right or wrong? In other words, ethical standards that we humans know, perhaps the AI algorithm would not know. Is it similar to what you had in mind or different?
Yeah, pretty similar. It's like the idea that they are getting held back almost by trying to replicate everyone, but a human more or less is only replicating what it's seeing on that day-to-day basis. If you were to throw an American person into India per se, are they going to pick up some of those cultural elements pretty quickly?
Hmm.
Absolutely. I don't think an AI can adapt that quickly.
And that's why I hear often there is a human at the end of the AI who is making right or wrong decisions from the output produced by AI. Let's take healthcare. If an AI algorithm is reading lung cancer lesions, it might hallucinate and get it wrong, and that's why you need a radiologist at the end to confirm the results. So you might not completely rest on AI until you could rest on AI. We will see when that time arrives. Sean, what were your perspectives on this difficult question?
Yeah. I was trying to think about like what industry could AI not disrupt, and I think like over the next like 20 years, like we're gonna see like a lot of software, um, and even like physical labor moved to like AI and robotics. But I think this is sort of similar, Arjun, and what you guys were talking about with the moral compass. I think the emotional intelligence is going to take much longer. I'm still a little bit optimistic that eventually
Yeah.
AI will be able to develop emotional intelligence, but I don't think we'll be seeing that as soon as all of the physical labor and like the mental intelligence that we're seeing today.
Sure. Maybe AI won't be as paranoid as we humans are.
Yes.
For better or for worse.
We'll see. We'll see. Is it Terminator or something else? All right. Excellent. I can't believe it. I'm having conversation with 17-year-olds here. But guess what? Your data set is much, much wider and broader than many others. All right. Awesome. So the future of Synodic, where do you want to take your company?
So right now at Synodic, we're trying to automate like the whole object detection process. So we talked about earlier how it's much faster to collect images and auto-label images on Synodic, and we're just trying to push this further in like every direction. So we're always incorporating the latest open source models, and we're working to develop and improve upon them with certain like fine-tuning techniques and like prompt generation. So we're always just trying to innovate and improve our product as much as possible. So in the near future, you can expect some improved image search. So we're working on improving the way that when you type a prompt, it searches for images. And currently, if you search like a really specific image, so maybe you're trying to find a bunch of pictures of a specific book, it would really struggle with that. But we're working to solve that issue. And but in contrast, it like excels at general topics. So if I was looking for a data set of construction workers with and without construction hats, it would excel there. But those specific issues, those specific queries we're working on solving. And then in auto label, as the open source models improve, we're just trying to incorporate them as fast as possible so the users see the benefit of that. And for auto train, we're of course trying to lower the price as much as possible and try to reduce the overhead on the GPUs to make it as cheap for our users as possible.
Okay. All right. Arjun, any additions to Sean's
Yeah,
response?
certainly. So I think Sean did a great job talking about the product, how we can make our own product better. So I think I'll talk a little bit about the outreach side, the business side. Something that I really do like about the field of computer vision is that I like to think of it as an untapped market. There are a few large players, but really, if we look at every potential beneficiary of computer vision, every company that can stand, or not even companies, just people in general that can stand to gain from computer vision, it is nearly untapped. There's very small percentage, and that could be from day-to-day people who could, for instance, figure out if their food is burning just from having a small computer vision camera in their kitchen, or it could be from small to medium size manufacturing companies being able to implement computer vision. Right now, only the largest corporations, and not even most of them already, are really taking advantage of computer vision. They're signing those large deals with those large computer vision players. But the rest of those that I just talked about are completely left in the dust. Something that we really do like about our product is speed is at the forefront of it, and time is money, right? We can implement for a person, for a company, much faster than the legacy computer vision players. So we can charge a lower price while still making our margins healthy by just being faster than them. We can implement in a few weeks instead of a few months, and we can really get that manufacturing line up and running sooner. We can tap way more businesses and people. So that's where I want to take this, or we want to take this. Yeah.
Sure. From an entrepreneur's perspective, would you like to hold on to your ship, or would you like to sell it off to a bigger fish?
We talk about this a lot, and it's a really tough conversation because we talk about like raising investment. Currently, like Arjun and I own 50-50, but we could bring on other investors and possibly grow faster. But I think right now we're focused on just providing like a really amazing product for our users, and starting to build out, like working with smaller businesses and other startups to try to help them with computer vision. And we're not really focused on investment right now, but there's always a time in the future. So.
Yeah. I
Right
like
now-
the answer. Arjun, my 2 cents. Build
Yes.
a great product and the world will follow you. But back to you, Arjun.
That's what we say.
Yes.
And I think right now in the AI landscape, that's really how it's going to work. If we just look at the big fish, the whale, OpenAI, right? Just look at how much money they have gotten after they have released their frontier model, Chachi BT, right? They didn't have that much money when they first started, but once they released that quality product, once they really showed the world what they can do, and really they didn't. I mean, their first few models were okay, but once they got that high quality model, the money followed, and I think we see the world in the same way, so we're not worried.
Very wise of both of you. Excellent. So far, this has all been nerd talk and entrepreneur talk, right? We'll move to the talk on culture. So this is the Indian Diaspora Podcast, and we're going to be talking about things Indian or Indian American. And Sean, you're welcome to give your ideas as well. Arjun, your parents were born in India. You were born here in America. What does being Indian American mean to you?
It's certainly a mix of things. I would say that I really do get a lot of perspectives because I have my Indian friend groups, I have my grandparents and relatives back in India, and then I have my non-Indian, my American, my Asian, whatever it may be, other friend groups. So I really do get that diversity of perspectives being an American Indian. And something that is like really amazing is how in India there is that chug spirit where just like put as much effort into something as you can, and that is something that I try to embody at least a little bit. But then there's also that American perspective of have fun while you're doing it, and that's something I try to do as well. So I really do think I am able to have a more diverse and more maybe not perfect lifestyle, of course, but I think I'm happier because I'm able to get the diversity of perspectives. So I really don't think you can get that.
I know, I love your answer. Sean, that chug attitude of India is called Jugaad. Jugaad, Jugaad. Somehow, anyhow, we get to what we want to achieve or get things done. In America, we call it the hustle culture.
Yes.
Excellent answer, Arjun. Sean, how do you see India, and what do you know of India?
Well, So throughout high school, I have a really diverse group of friends. I have friends like Arjun. I have friends with the other people from India, or their parents are from India, as well as like Asia and Europe and all the rest. But I've just noticed that like we're all everyone's like really like welcoming, and they work like really hard, and I think that's like a wonderful spirit to have, and I hope to also have that like working hard spirit. So yeah.
I promise he does have it.
Same with Arjun.
Excellent, excellent. Sean, have you traveled to India?
I have not, no.
All right. As an entrepreneur and as somebody who loves AI, I'm really curious to hear your perspectives after you've traveled to India, gone to the tech hubs of Bangalore, or other cities like Hyderabad, Mumbai. I'm sure where a lot of innovation is happening. There's a lot of hunger among younger kids in India now, and there are schooling systems as good as those of Massachusetts in India now. So, you know, travel, my friend.
That's really exciting. I'll have to visit sometime.
Excellent. And your data sets definitely is going to expand in your brain's AI model.
100%.
Arjun, when you travel to India, how do you feel? What are your perspectives?
There's really two big things that I find completely different. So one, there's of course the culture. There really is that mentality. You can see the chug, how every person who isn't as fortunate as others works 7 days a week, and it's not to say that that doesn't exist in the U.S.,
Mm-hmm.
but there is that higher level of poverty. There is that hunger. There is that space constraints where people are not able to make ends meet, and that it exists here too. We just don't see it as much living where we do in Massachusetts. So there is that. There is also really, it's an interesting place to be, considering it's 1.4 billion people in a country a third the size of the US. So that's 3 times the population in a third the size. So you really do get just that tight, bubbling atmosphere almost. Every single restaurant you go to, every single shopping mall you go to will have at least 3 times the number of people you would see in a US based one. And something that I do hope to also see there in the future, which I sadly don't see there right now, is a little bit of diversity. I would like to see other cultures there. So that is something that is very interesting, where you go there and you really are only seeing Indians, but there are benefits and drawbacks to that too.
Yeah. Excellent. Excellent. All right. This has been a great conversation. So we'll come to the last segment, which is rapid fire questions. It's going to be a fun segment. Don't think, just express yourself. Yeah. I'm going to ask a question. Arjun, you go first, and then Sean, you.
Okay.
Yeah. All right. So the movie with a technology theme that you would recommend everybody watch.
I'm gonna go basic on this one.
Mhm.
I'm gonna go Avengers. I really do think, and there is a little bit of the mythical aspect to that as well, the fantasy. But I really do like the fantasy land that they produce. It's the idea that anything can happen. So through technology, of course.
And I'll share a little bit. Sure. I'll share a little bit of like a different perspective on this question. So my favorite movie of all time has to be Interstellar. I think it's just such a beautiful story, and it's so cool, all of like the accurate technology that they implement in it. And I was so surprised when I walked away and I learned more about like time warping and the effects of being in a different like gravity field from a movie. So it was just like a really amazing movie. It's beautifully produced, and you learn so much.
Next, Arjun, a book that everyone who's building a tech company should read.
This is not specific to tech, but there is a beautiful book called Redeployment. and this has, by the way, nothing to do with technology. It is about the U.S. invasion of Iraq, but it really does just talk about how everything has consequences, how
Hmm.
things may not, like, how what you do doesn't just have consequences on the things you touch. There are secondary, tertiary, quaternary consequences of everything that happens. And I think that's especially important in the world of AI, where so many things are touched.
Sean?
I think I'd have to say The Singularity is Near by Ray Kurzweil. That's one of my favorite books, and it's about how the compounding S-curves of technology create an exponential growth in different technologies and different industries, and it's so fascinating. And it was like a pretty new perspective when it was launched, but now it's sort of accepted in the world today.
Hmm.
So I just thought it was a really interesting perspective on technology and like what technologies are going to be big in the future.
Hmm. Excellent. Next question. A person from the computer science world that everyone should know about.
I'm gonna go, and by the way, I apologize for absolutely butchering his name, but Ilya Sutskever. That's how
Okay.
I think it's pronounced.
Okay.
But he is one of the he was one of the chief technology people at OpenAI. But really, his work in perfecting transformers and the math around that is just phenomenal, and just the complexity that he brought to the table, his way of changing the conventional views of machine learning is really groundbreaking. And it doesn't even just apply to AI. It's just like the way how everything can change with just the dream, really, because it's just phenomenal what they've been able to develop. So
I agree. Sean?
Yeah, so I'm gonna try to sneak in two people, but they're under the same umbrella. So the two people are George Hotz and Andrei Karpathy. So Hotz founded, among other things, he founded Comma AI, which is a self-driving startup, and they're doing extremely well. And I think um, outside of that, he offers a lot of interesting perspectives on technology and what to focus on. And he's truly like one of the best programmers of our time. And in addition to that, Karpathy, sort of a similar angle. He was the self-driving lead at Tesla, and now he also was a founding member of OpenAI, and he was a professor of machine learning at Stanford. So he's been all over the map, but he really is like an amazing teacher, and he really distills like the AI concepts down to something really simple that everyone can understand. So
Excellent. Excellent. Love the answers. Finally, your favorite Indian dish, Arjun?
I'm gonna go simple on this one, but I really do like myself a good dal fry with rice. So don't know why, could not tell you, but something some people ask me, it's like, if you could eat one dish for the rest of your life, what would it be? Easy answer, dal fry.
Excellent. Sean, have you tried Indian food? Your answer?
um, a little bit, but I'm not too familiar to name a favorite.
Sorry, what did you say?
I've tried Indian food a little bit, but I'm not too familiar
Oh,
to
okay, all right,
name
all
a
right. We'll give you a pass. So,
thing.
Arjun, your responsibility. All right, excellent, excellent. So, Arjun and Sean, this has been a very intellectual discussion. Not only have we talked about your company, Synodic, but we've also talked about artificial intelligence and rather the future of it with respect of humanity, and that too coming from two 17-year-olds. And I asked some tough questions to you that you tried to, take on with your pure reflective thoughts at this young age, which I really enjoyed. So thank you for sharing your experience. Now, to close this podcast, Arjun and Sean, if there's any young boy or a girl, a teenager or eighth grader in Bangalore or New York, or anywhere around the world who wants to build a company like yours, what would you say to that boy or girl?
I think my message to them would be to just start. If we, instead of just like starting to write the code for Synodic, if we planned everything out in excruciating detail, we would be nowhere where we are today. So I think just starting and like making a ton of mistakes has really been beneficial for us.
Totally agree. Back to like what I was saying, like quantity over quality. Just if you like something, give it a shot. What do you have to lose as a kid? It's like I don't think at least I don't think I have seen a better way to figure out what you really like other than just doing it. I like Sean said, don't plan too much. You really just need to expose yourself to it, and then I think everyone will succeed if they can do that.
Encouraging thoughts there. Thank you so much, Sean and Arjun, for joining us in this podcast, and for all those who listen to us. Thank you for your time. Hopefully you enjoyed this podcast and are energized by the energy of these two teenage prodigy stars. Thank you, everybody. Closing the podcast now.